Hi friends, welcome back to our YouTube channel. Today we have to discuss about queue operations in data structures course and advanced data structures course. Before going to the queue operations, first of all, what is queue? Queue is a linear data structure in which insertion can be done at the rear end and deletion can be done at front end. Queue works on a principle called FIFO. FIFO stands for first in, first out. Whatever the element which is inserted into the queue first, that element can be deleted first. Now we can go for queue operations. There are three queue operations can be performed on the queue. First one is enqueue operation. Second one is dequeue operation. Third one is display operation. Now we can discuss each and every operation with elaborated code. So enqueue operation is mainly used for inserting element into the queue, inserting element into the queue. Inserting element into the queue. Enqueue operation is mainly used for inserting element into the queue. What are the steps we have to consider while performing enqueue operation? The first step is a rear value can be incremented. The second step is whatever the element we want to insert, that element can be inserted into the queue of rear. So these two steps we have to follow while performing enqueue operation. First one is rear plus plus. Second one is queue of rear is equal to element. Now we can go for the code. Void enqueue if rear equal to size minus 1, we can say that printf queue is overflow. Queue is overflow. Else printf enter the element. Enter the element we want to insert. That element can be read from the keyboard by using scanf function. Scanf %d double quotes and ampersand element. Next, rear plus plus. Rear value is incremented. Next one, whatever the element that we are read from the keyboard by using scanf function, that element can be assigned to the queue of rear. Here one more condition is checked. If front value equal to -1, front value is pointing to -1. First element we are inserted into the queue, at that time also front value is incremented. So this is the code for Enqueue operation. So before tracing our code, so we are taking a diagram. This is a queue diagram. Size of the queue is 5. That means it can store only 5 elements, so that the indexes are starting from 0 to size -1. So that is 0 to 4. 0, 1, 2, 3, 4. Next one, rear can be denoted by small r, front can be denoted by small f. Initially, both rear and front pointing to -1. So, rear r equal to -1, front f equal to -1. Whenever r value equal to -1 and f value equal to -1, we can say that Q is empty. Now we have to trace our code. So first, void enqueue. The enqueue operation does not return anything, so that we have to write void before enqueue. Next one, if rear equal to size -1. Initially rear value pointing to -1. So -1 equal to size of the queue is 5. 5 minus 1. So that is 4. -1 equal to 4. So that is condition false. If this condition is false, then control goes to the else block. In the else block, these are the statements that we are executed. Printf, enter the element we want to insert. Now I am inserting element 10. So that element value 10 can be read from the keyboard by using scanf function. After reading the element 10 from the keyboard by using scanf function, next one is rear value can be incremented. So now rear value can be incremented. -1 is incremented by 1. So then rear value equal to 0. Rear value equal to 0. Next one, Q of rear equal to element. Element 10 can be assigned to the Q of rear. So this is the Q, this rear pointing to this one. Now we are inserting element 10 into the rear end of the Q. Next one, if front equal to -1. Yes, front value is -1. So -1 equal to -1. So condition true. If this condition is true, front value is also incremented. So now f value is 0. Generally, while performing insert operation, rear value is incremented. While performing delete operation, front value is incremented. But this condition is occurred generally. Initially, both rear value is pointing to -1, front value is pointing to -1. Whenever the first element is inserted into the queue, at that time both front value is incremented and rear value is incremented. So -1 is incremented to 0 of rear end, -1 is incremented to 0 of front end. So this can be applicable only whenever we are inserting first element into the queue. After that, while performing insert operation, rear value is incremented. While performing dequeue operation, front value is incremented. Okay, so front value is incremented. Okay, next. Now we are inserting element 20 into the queue. So void enqueue if rare equal to size minus 1. What is the rare value now? 0. So 0 equal to 4. Condition false. Then go to the else block. Printf, enter the element. Scanf percentage d ampersand element. Element 20 can be read from the keyboard. Next one, rare value is incremented. So now rare pointer pointing to this one. Now R value is 1. Next one, F value is 0. After incrementing rare value, R value is 1. Next one, which element you want to insert? Element 20 we want to insert into the queue. So element 20 can be assigned to the queue of rare. Rare pointing to this one. Element 20 is inserted into the queue. Next one, if front equal to minus 1, what is the front value? Front value now 0. 0 equal to minus 1. So that is false. Then go to the next statement after the if block. There are no statements are there. So now it is end. Next we are inserting element 30. Void enqueue. Next one, if rare equal to size minus 1. What is the rare value now? 1. 1 equal to 4. So condition false. Go to the else block. Printf, enter the element you want to insert. That is 30. 30 can be read from the keyboard by using scanf function. Next one, rare plus plus. Now rare value is incremented. It pointing to 2. Next one, the element 30 is read from the keyboard. That can be assigned to the queue of rare. Rare pointing to index 2. Now we are inserting element 30 at index 2. Next one, what is front value now? 0. 0 equal to minus 1. This condition is false. Control goes to next statement after the if block. There are no statements are there. Next again we are inserting element 40. Void enqueue. Next one, if rare equal to size minus 1. What is the rare value now? 2. 2 equal to 4. Condition false. Then control goes to the else block. Printf, enter the element scanf percentage d ampersand element. Element 40 can be read from the keyboard by using scanf function. Rare plus plus. Now rare value is incremented. Now rare value is 3. Next one, whatever the element that we are read from the keyboard, so that is 40. 40 can be assigned to the queue of rare. Rare pointer pointing to index 3. In that one, we are inserting element 40. Next one, if front equal to minus 1. Front value 0. 0 equal to minus 1. So that is false. Control goes to the next statement after the if block. There are no statements are there. The enqueue operation is completed. Next, now we are inserting element 50. Void enqueue if rare equal to size minus 1. What is the rare value pointing to? 3. So now 3 equal to 4. So that is condition false. Then the control goes to the next statement after the if block. So that is else. In that else, printf, enter the element you want to insert. Scanf percentage d ampersand element. So now we are inserting element 50 into the queue. That element can be read from the keyboard by using scanf function. Next, rare incremented. Rare value previously 3, now it is incremented. Now rare value is 4. Next one, queue of rare is equal to element. Which element we are inserting? Now 50 is inserted into the queue. So that element 50 can be assigned to the queue of rare. Rare value pointing to 4. Now we are inserting element 50 into the queue. Next one, if front equal to minus 1, front value 0, 0 equal to minus 1, condition false, control goes to the next statement. After the if block, there are no statements are there. Now enqueue operation is completed. Now we want to insert element 60 into the queue. Void enqueue. Now if rare equal to size minus 1, what is the rare value now? 4. 4 equal to 4. Condition true. If this condition is true, the statement within the if block is executed. So printf queue is overflow. Okay. So because queue size is 5, so now queue is filled with 5 elements. Again, we want to insert one element into the queue. If the queue is already full at that time, so queue is overflow condition is occurred. Okay. So what is queue overflow? Queue size is 5. Queue is already filled with 5 elements, but now we want to insert one more element into the queue. At that time, queue overflow is occurred. Okay. Next, we can go for dequeue operation. Next one, dequeue operation. So dequeue operation is used for deleting element from the queue. Deleting element from the queue. Next, what is the algorithm we have to use for dequeue operation? So void dequeue if front greater than rare, printf underflow condition is occurred. Queue is underflow. Sorry, queue is underflow. Else the element can be deleted from queue of front. Element is equal to queue of front. After that, front plus plus. Suppose we want to delete the element that we are deleted from the queue. So printf deleted element is %d double quotes and comma element. Else block close, dequeue function is close. Here, while performing delete operation, we have to follow two steps. The first one is whatever the element that we want to delete, that element can be deleted from queue of front. Whatever the value that is present at queue of front, that element can be deleted, that element can be assigned to the element. After that, front plus plus, front value can be incremented. So these are the two steps we have to follow while performing dequeue operation. So void dequeue, brace begin, if front greater than rear. If the front value is greater than the rear value, we can say that printf queue is underflow. If this condition is false, then go to the else block. We are deleting the element from the queue of front that can be assigned to the variable called element. After that, front value can be incremented. Suppose we want to print the deleted element. So this statement is executed. Printf deleted element is %d element. Okay. Now we are tracing our code. So in the previous enqueue operation, this is the queue we are getting. Queue size is 5. It can store 5 elements, 10, 20, 30, 40, 50, and queue index starting with 0 and ending with index 4. Okay, so queue of 0 contains element 10, queue of 1 contains element 20, queue of 2 contains element 30, queue of 3 contains element 40, queue of 4 contains element 50. Okay, so rear pointer pointing to 4, front pointer pointing to 0. Okay, now we have to trace our code. Void dequeue. Dequeue operation does not return anything, so that we have to write void before the dequeue function. Brace begin. If front greater than rear, what is the front value here? 0. What is the rear value here? 4. 0 greater than 4. Condition false. If this condition is false, then the control goes to the next statement after the if block. So after the if block, else statement is there. The statement within the else block are executed. So queue of front. So what is the front value now? Front value is 0. So queue of 0. So front value is 0. Now queue of 0. What is the queue of 0 contains? Queue of 0 contains element 10. That element 10 can be deleted from the queue. Then it can be assigned to element variable called element. After that, front plus plus. So front value previously 0. Now it is incremented. Now front value equal to 1. Next, printf the deleted element is %d double quotes and comma element. So what is the element value here? The elements that are deleted from the queue are, so 10. 10 is deleted from the queue and it is printed. Next, again we have to perform the dequeue operation. Void dequeue, brace begin, if front greater than rear. What is the front value now? Front value now 1. 1 greater than 4. Condition false. If this condition is false at if block, then control goes to the else block. In the else block, now queue of front value is 1, so queue of 1. What is the queue of 1 contains? Queue of 1 contains element 20. That element 20 can be deleted from the queue, that can be assigned to the variable called element. Next one, front plus plus. So now front value is incremental. Previously it is 1, now it is 2. After that, printf the deleted element is. Which element we are deleted from the queue? 20. That element can be printed. 20 is printed. Again, we are performing the Dequeue operation. Why Dequeue? Let's begin. If front greater than rear. What is the front value now? Front value is 2. 2 greater than 4. Condition false. If this condition is false at the if statement, then go to the else statement. In the else block, these statements are executed. Element is equal to q of front. Now, what is the front value? 2. Q of 2. Q of 2 contains which element? So that is 30. 30 can be assigned to the variable called element. Now the element contains value 30. Next, front plus plus. Front value previously 2. It is incremented. Now front value is 3. Next, printf, the deleted element is %d double quotes and element. Element value is printed, that element value is 30. 30 is printed. Again, we have to perform the Dequeue operation. Why Dequeue? Let's begin. If front greater than rear. What is the front value now? That is 3. What is the rear value now? 4. 3 greater than 4. Condition false at if block. Then control goes to the else block. In the else block, these are the statements are executed. Element is equal to q of front. What is the front value now? 3. Now q of front means q of 3. Q of 3 contains which element? Q of 3 contains which element? 40. So 40 can be deleted from the q, that can be assigned to the variable called element. Now the element contains 40. Next one, front plus plus. Now front value previously 3. Now it is incremented by 1. Now front value is 4. Printf the deleted element. The deleted element is 40. 40 can be printed. Again, we have to perform Dequeue operation. Void Dequeue, brace begin. If front greater than rear, front value is, what is front value now? 4. 4 greater than 4. That is false. Now the condition at if block is false, then the control goes to the else block. In the else block, these are the statements are executed. Element is equal to q of front. What is the front value? 4. Now q of 4. So q of 4 contains element 50. 50 can be deleted from the q and it can be assigned to the variable called element. Now the element contains 50. After that, front value is incremented. So now front value is 5. Printf deleted element is, which element we want to print? That is 50. The deleted element is 50. 50 can be printed. Again, we have to perform Dequeue operation. Void Dequeue, brace begin. If front greater than rear. What is the front value now? 5. What is the rear value here? 4. 5 greater than 4. So that is condition true. If this condition is true, then the statement within the if block is executed. Q is underflow. Okay. In which case Q is underflow condition is occurred? Here the Q is empty. After the Q is empty, again we have to perform Dequeue operation. So then Q is underflow condition is occurred. So trying to perform Dequeue operation when the Q is empty, then that condition is called as Q underflow condition. What is Q overflow? Trying to perform Enqueue operation when the Q is full. At that time, Q overflow condition is occurred. So this is the Dequeue operation with algorithm. Okay. Next, we can go for display operation. Is display operation. So display operation is used to display or to print. To print or display elements within the queue. So display operation is mainly used for displaying or printing all the elements within the queue. Then what is the code for display function? So we have to write algorithm void display While performing the display operation, first we have to check whether the queue is empty or not. To check whether the queue is empty or not, the condition is if front equal to -1. If the front equal to -1, we can say that printf queue is empty. Suppose if front equal to -1 condition is false, then go to the else part. In the else part, we have to display all the elements within the queue. For I is equal to front semicolon, I less than or equal to rare semicolon, I plus plus. So printf %d, here we are giving one space, queue of I. So this is the code for display operation. Okay, so display operation is mainly used for displaying all the elements within the queue. So in the display operation, we have to check first whether the queue is empty or not. What is the condition for checking queue is empty? If front equal to -1. If this condition is satisfied, we can say that queue is empty. If the condition is not satisfied, then we have to print or display all the elements within the queue by using this statement. For I equal to front, I less than or equal to where, I plus plus, printf %d queue of I. Okay, now we have to trace our code with this example. So first one, void display. Here display function does not return anything, so that we have to write void before the display function. Brace begin if front equal to -1. Okay, so what is the front value here? Front value is 0. So here I am writing f equal to 0. So f value is 0, 0 equal to -1. So condition false. If this condition is false, then control goes to the else block. In the else block, for I equal to front. What is I value? What is I value now? What is the front value now? Front value is 0. So I equal to front value is pointing to 0, so that front value is 0. Now I value is 0. I less than or equal to 0. 0 less than or equal to, what is the rare value now? 4. 0 less than or equal to 4. Condition true. If this condition is true, the statement within the body of the for loop is executed. Printf %d queue of I. I value is 0. Queue of 0. Queue of 0 contains which element? So 10 is printed. After printing, one space is there. Next, after printing 10, again control goes to the for loop I plus plus. Now I value is previously 0, it is incremented by 1. Now I value is 1. I less than or equal to rare. So 1 less than or equal to 4. Condition true. If this condition is true, the statement within the body of the for loop is executed. Printf percentage d q of I value now 1, q of 1. Q of 1 contains which element? 20. 20 is printed. Again control goes to the for loop. I value is incremented. Now I value 2, because previously it is 1, it is incremented by 1. So now 2. I less than or equal to 2. Now I value is 2. 2 less than or equal to 4. Condition true. Then control goes to the body of the for loop and execute the statement within the body of the for loop. Printf percentage d q of I. Now I value is 2. Now q of 2. Q of 2 contains element 30. 30 can be printed. Again control goes to the for loop. Now I value is incremented. Previously I value 2. Now it is incremented by 1. Now I value is 3. I less than or equal to rare. So that is 3 less than or equal to 4. Rare value 4. So condition true. If this condition is true, then control goes to the body of the for loop and execute the statement within the body of the for loop. Printf percentage d q of I. Now I value is 3. Q of 3 element is printed. Q of 3 element is 40. 40 is printed. Next, again I value is incremented. Previously I value is 3. Now I value is 4. I less than or equal to rare. Now I value is 4. Rare value is 4. 4 less than or equal to 4. Condition true. The statements within the body of the for loop is executed. So printf percentage d q of I. Now I value is 4. Q of 4. Q of 4 contains element 50. 50 can be incremented. Next I value is incremented. Now I value is 5. I less than or equal to rare. I value 5, rare value 4. 5 less than or equal to 4. Condition false. If this condition is false, the control goes to the next statement after the for loop. After the for loop, there are no statements are there. So what are the elements that are printed? 10, 20, 30, 40, 50. So the elements within the queue are 10, 20, 30, 40, 50. So this is the code for display function. So I hope all of you understanding the queue operations. So first one is enqueue. Enqueue is used for inserting the elements into the queue. Here we have to consider two steps. First one is rare value is incremented. Then q of rare is equal to element. Second one is dequeue operation, that is used for deleting the elements from the queue. So here also we are considered two steps. First, the element which is there at the queue of front, that element can be deleted from the queue. After that, front value can be incremented. Third one is display. So display operation is mainly used for displaying all the elements within the queue. Here we have to check one more condition, if the queue is empty or not. If the queue is empty, so we have to print there are no elements are in the queue. Hence we can say that queue is empty. Otherwise, we have print all the elements within the queue starting from front and ending with rare. Okay, so here while performing enqueue operation, so under a queue overflow condition is occurred. So what is the condition for queue overflow? Rare equal to size minus 1. If this condition is satisfied, we can say that queue is overflow. While performing dequeue operation, queue underflow condition is occurred. Queue, what is the queue underflow condition? front greater than rear. If the front value is greater than the rear, we can say that queue underflow condition is occurred. Okay, so this is the queue operations with code also. In the comment box, introduction to queue video link and queue operations using array implementation program link also available in the comment box. Please refer that videos also. If you really understanding this video, please subscribe my YouTube channel Divvela Srinivasa. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. If you really understanding this video, please share this video to your friends and classmates. Thank you one and all for watching this video.